which one of you is the flat earther?
Me. Well, look, I mean, I got
Nice. I like that shirt. There you go. And Dan, where do you stand?
I'm open-minded. I'm the skeptic slash. I'm not smart enough to really understand, so I'm willing to listen to anybody's opinion.
So you're open-minded, appeal to authority kind of guy.
Uh, no, I don't appeal to authority at all. I'm more.
look at his astronaut shirt.
Okay. Well,
Go ahead, Jeff.
just when you say that I'm not smart enough to know, are you on a swivel chair right now?
I am, yeah.
Yeah.
If I spun you around, are you smart enough to know you're spinning?
I am the highest version of myself. I'm the highest version of myself. I know I am that I am.
Hey, welcome to another episode of the Godspeed Podcast. I am your host, Joe Guy,
And I am Dan Eats Everything.
and we have a special guest today, Flat Earth Dave.
Hey,
What's up,
flattery
guys?
day.
Hey, thank you so much.
Welcome.
So, on my right, I have sensible, common sense Joe, who knows the Earth is flat, and on my left, I have, well, at least on my screen, it'll probably come out backwards, so I'll seem like a crazy flat earther. I have Dan, who is open-minded
Open-minded.
and doesn't think he's smart enough to know if he's spinning around.
Willing to listen. Willing
Well,
to
always listen. I like it.
I got some questions too, so that's good.
You guys are going to leave, but I just want to start with a question for you.
Shoot.
Are you in a cult? Are you in a cult?
No, I don't conform to any religion. No.
That's good. That's good. So all of your beliefs are based on something.
Life experience, yes.
Like you're wearing a tie-dye shirt. You have a belief you're wearing a tie-dye shirt. You can show me some evidence you're wearing a tie-dye shirt. Your experience with tie-dye shirts is somebody usually makes them by hand, or maybe there's an automated way to make. Oh, you make that. You made that shirt.
I made this. Yes.
Very nice. Very
Thank
nice.
you.
There's an
So,
astronaut
so that
on it.
belief is not a cult religious belief at all. That is a scientifically provable world experience belief.
Correct.
However, today, when we're done, if you think you live on a ball, you're going to have to admit that you're in a cult with zero evidence of what you believe. All right?
I'm not going to agree to that.
Let's have you, Joe and I, where we're wrong.
Oh no, that's not how this goes. This podcast goes as Joe tries to convince Dan Eats Everything of his theories, and he's been, I think, 50-50. We've agreed on some things so far. This is the one I've had the most pushback on, I believe. That's why he wanted to bring on the expert.
Okay? Very good. So
So basically, what he's saying is he has no proof at all that he lives on a globe. Is what he's saying.
that's what he's saying. But
Other than
out of that ball.
I mean, other than what I believe, I think like 90% of the rest of the people on this planet believe, and what everyone.
Thank you. We'll take 10%. We'll take
Yeah,
that.
hey, it's a growing number, right?
I think when we hit like 2%, it's going to flip. So
But yeah, so other than what I've been taught my whole life and what is supposed to be common knowledge for most humans,
what does taught mean?
somebody has information and they teach others.
So if a teacher read you a book by Dr. Seuss, are you being taught facts? Or are you being told a story?
No, that's told a story. Yes,
That's a story. That's a fictional story.
correct.
When you say you were taught, you were told things, and to be taught, there'd have to be something to back them up, right?
Yes.
So we're going to look for those things today because I'm having trouble finding them.
Okay.
Maybe you can help find them. Did you ever watch Sesame Street as a kid?
I remember Sesame Street. Yeah.
So Sesame Street was doing a piece, and they were explaining what fiction is. Hey, Elmo, this is the fiction section. This is the fake stories. What is on top of the fiction section? Are they telling us something? The globe and a rocket is on the fiction section. Are they? Is that, I call that revelation of the method, where they always have to tell us the truth.
Okay, yeah, Joe's mentioned this.
Multiple episodes.
Yeah, so far.
Yeah. And just education, modern education, right? Creating people who are smart enough to repeat what they've been told and follow orders, and dumb enough to think that that makes them smarter than everyone else. You said at the beginning, I'm not smart enough to know that I'm spinning, whirling, and twirling in 4 different directions at incomprehensible speeds through a space vacuum, which is scientifically impossible. I think you are. I just met you.
Well,
I think you're way smarter than that.
I've been brushing the shit out of my teeth, and I know that fluoride is dumbing me down. So, you know.
You might, if you've been doing that with a lot of fluoride, I retract my statement. I totally retract my statement. Okay.
Oh my God.
Before we get into this, if I was near you guys, would you guys be up for a barbecue tonight?
Yeah.
Yeah.
But I don't have any propane, so I want you Dan to go out and get some propane, but I don't like tank, so just bring back the propane, no tank. Okay.
Okay, I can do that. Yeah, for sure.
Explain to me how you're gonna do that. You're gonna
I'm gonna put it in a bag.
Well, that's a container. I don't like any containers.
Oh.
Okay, but maybe you got a basketball and if you put it on the outside of the basketball, would that work?
No,
it wouldn't. Hey, you are smart. Okay, that's about as much intelligence as you need to understand that you can't have a rocky water ball with air, gas, propane, whatever on the outside adjacent to a void. I'm not even asking you to get me a basketball with propane on the outside adjacent to a void. I'm saying bring it back in our pressurized atmosphere, okay? Which is a lot easier than a space vacuum, a void adjacent. So we can pretty much rule off that we're not a ball with air on the outside adjacent to a void. Could you agree with that?
Yeah, I mean, I don't know. I'm not a scientist.
Welcome to Flat Earth. Welcome. I'm not a scientist. Dan, have I spoken with you before? Have we spoken before? I think we did. No? You were with somebody else.
Do you watch a lot of gay porn?
I do. Yeah.
Oh, well, that's maybe we have spoken. I don't know.
Yeah, maybe. So and my anti-flat Earth cult followers will take that clip and they're gonna just run with it. It's all right. And I had a great point, and you threw me off. It was a great point. It was a great point.
Oh, I'm so sorry.
What was I saying just before that?
He's not a scientist.
I'm not a scientist.
You're not a scientist, but you're not a complete buffoon. Okay?
Oh, you're a kind man.
You wanna say you don't know anything, but you can navigate life pretty well. You can go, you know when you need groceries and how to go out and get groceries. You can do a lot of complicated things. Knowing that you can't put propane on the outside of a basketball and bring it to a barbecue is the same thing as knowing you can't have air on the outside of the earth, ball, water, adjacent to a void, and have it exist. Okay? Here's another question. Gas violently fills the available space. Like if you had a balloon and you put it in a room, they sucked all the air out of the room. What happens when you open that balloon? Psh, fills the space. Or if you had a bottle filled with air, you brought it into a room that had no air, and imagine you could live in there. You open it, whoosh, it equalizes instantly. You open up a pressurized seltzer, soda, whatever, beer, and it goes, psh, that is just it equalizing instantly, right? If you have let's say we have a 2-foot square plexiglass box and we sucked all the air out of it. So it's on my own portable zero pressure vacuum. If I opened up a valve on the side, bottom, or top, doesn't matter, at any altitude, it's violently going to fill with air. Not because it's sucking it in, it's because the air pressure is trying to fill the available space to equalize it. That's why we have wind. High pressure next to low pressure will equalize until it's equal, and then the wind stops. So
I understand that. It wants to fill the void. So you brought up air pressure. Explain to me, how does weather work in a flat Earth system? Because that part confuses the shit out of me.
Well, what do you mean? How does weather?
Like weather patterns and You pull up a picture of radar or weather
Are you
radar.
talking about HARP?
I don't know what I'm talking. I'm talking about the way the weather patterns work. Like you get low pressure air coming this way constantly. I just don't understand how weather patterns work. If we're like supposedly we're in a firmament, right?
Right. So these are the sun's rays coming in, right?
Right.
From the sun's incredibly far away. So all the rays come in parallel, even though no one has ever seen parallel rays. They all come in like a local light. But here it is. And they say when you're tilted away, like up north, you're tilted away. So that sun ray, that makes it colder. Here
Right.
would be the
Not as hot.
hottest.
Not as
And here
more
would be
intense, right?
colder again because you're tilted away. And then these poles are really cold, And this is the northern. If the north is at the top, and north is here's America. It's the northern summer and southern winter. Okay, because we're tilted towards the sun. So the Earth is spinning. How come this heat map isn't across the middle? How come it's at this angle? How come, because this should be the hottest part right around, all the way around this. It shouldn't be at an angle like that. It should be straight across, right? But if we look at the flat Earth with the sun, it goes in here is the Tropic of Cancer, out here is the Tropic of Capricorn, and the sun just circles around here.
Right. No, I understand that. But like supposedly we're in a firmament, right? How does wind how do we get these tornadoes and hurricanes?
Okay. Well, there's all sorts of electrical energy. There's all sorts of heating, hot and cold areas, and it's just everything is electrostatic. Everything from wind to you to food to rock, everything has an electrostatic charge. So we live in this giant electrostatic system, and you know that they show you in school. They teach you about the jet stream. It goes all the way up to Canada and then down, and it makes this big crazy sine wave, right? But when we actually look at it and we plot that on a flat Earth map, this is what it looks like. Okay, look at this. They're making perfect circles. Wind goes this way, and then wind goes this way in this red area. These red areas are like 200 plus mile an hour winds at like 40,000 feet. So you have these counter rotating vortices, kind of like we live in a toroidal field where the energies are spinning everything around. When you say, what causes weather? Well, the sun and the moon are the anode and cathode of this world battery system, and they circle around. So this is heating these areas. The moon actually makes it colder. So when there's a full moon, it's colder than when there's no moon. Okay? So you got heating and cooling. You got these jet streams. You got these energetic patterns spinning up out of the North Pole. Plenty of weather to be had there. Then on top of that, if you really want to get into it, another show completely. Almost all the weather is completely manipulated with the next rad radar.
Oh.
It's all the Jews, yes.
I'm just kidding.
HARP.
Just kidding. I'm gonna get canceled now.
Like I said earlier, HARP.
But they renamed it NextRad. You see these those giant golf ball ships, aircraft carrier things. Those are manipulating the weather. It's all controlled.
Okay.
It's all controlled. So that's how weather happens. There is some natural weather, and then there's the evil ones, manipulating it.
Okay. Well, I mean, I appreciate the answer.
This is just my opinion. There's my opinion. Just to believe, this world, we need rain for the plants to grow, and we need sun, and we need these patterns. Well, the sun, migrates in between the two tropics, goes around and around. But it's amazing that the water gets delivered to where it's needed most of the time, unless they're screwing with it, right, and causing these unnatural droughts. It's an intelligent system.
When was the last
It's
time
an
you got
intelligent
sriracha?
system. Well, you haven't had my hot sauce, have you?
Haven't.
Hot sauce is best, okay?
Hot sauce is the best.
Yeah, so
I'm sorry. I don't mean to throw you off. buddy.
Also, D, I know you don't. We don't have to get into Bible stuff, but there's literally passages in the Bible where he opens up windows.
Here's the
in
thing.
firmament.
I like to leave Sky Daddy out of it. All right, we're gonna skip Sky Daddy for now.
Bible and religion have nothing to do with each other.
but the thing is, there's so many proofs in the Bible There's so many proofs that we live in an intelligent system, and whoever that there is a creator. You don't need that to prove flat Earth. We don't need it. There's plenty of proof. Like, if I could show you one proof, let's go for one proof. All right, one proof would be we can see too far. Right. So here is J. Tolan Media. Now this is done with an infrared camera from Malibu, seeing Mount San Jacinto, if I'm saying that right, and we can see the whole mountain except down here. It's hard to see it because this is just the thickest atmosphere and we just can't see through it. Here's the problem. At this distance from this viewing spot, the very, very tip might be the only thing that's showing, but we can see the whole thing. Here's the other thing. Turn off the infrared, which cuts through the haze and takes that visible light out. And so the infrared, which can cut through easier, shows if you take off that filter, this is a perfectly blue sky with some smog, of course, and you can't see the mountain at all. Now, the Globers will say you can't see the mountain because it's over the curve, but then we put on an infrared camera, and they go, whoa, refraction. Like, wait a minute, what is it? Because infrared, if there is refraction, would refract even less, right? But the truth is, nothing hides behind something and refracts up and goes, oh, here I am, but I'm really over here. But here I am. Nope, I'm really over here. That never happens, okay? So we can see too far, right? And you're like, okay, well, what about without infrared? No? And I say, well, this is a recent one, and the globalists, I'll tell you what they say about this. From this viewing point, we're up high, no pollution, clear day, and we could see these 8 different mountaintops. Not mountaintops, you can see the whole mountain except the very bottom because there's things in the foreground that are blocking them. But we can see them. The tops of these mountains should be over 40 miles below a physical curve. Okay? Physical curve. This is a physical curve. Can you see my mouth? No. You zoom in. Can you see it? No, because it's a physical curve, right? But we can zoom in and we can see these mountains. They should be over 40 miles below the physical curve. 40 miles. Can you comprehend what 40 miles is?
I can, yeah.
40 miles is, this height is just down to these clouds, and then the Earth is below that. That's only 20 miles, though. Okay? It should be twice the drop that this balloon height is.
So, I guess my question would be like, what if the math is wrong? What if the Earth is way bigger than what they figured it out to be?
On episode 1, I showed you the math. That's the actual math. Like,
yeah, but what if the math is wrong? Like, because that would make more sense.
So hold on. The math is right for a 24,901 mile ball. But you're saying, what if it's a bigger ball? That's what you're saying, right?
Yeah, exactly.
So we have ship observations where we can see a ship and we can see the whole ship. And some people are arguing, well, the bottom's missing. You know, the bottom of the ship is missing. But then we can see other ships beyond that ship. And we can see the surface of the water. So I don't care if the bottom half of the water of it's missing. We can see it. Now this is what causes a false horizon are waves in the foreground. Okay, so I zoomed in on these ships that you couldn't even see, and you think this is your horizon, but watch these ships. Watch, it comes up. Right, look at the ship. Is this going behind a curve or behind a false horizon? So there's days out there where it's not so swelly like this. It's more just more waves. And then you don't see the up and down. You only see the down because the foreground is being hidden. Like if my finger was a wave, could my finger hide my whole face? No, unless that wave was closer to you.
Right.
That's what you're seeing here. So we have a ship measurement where we see a ship, and then we see this other ship, and by ship tracking, we knew exactly how far the other ship was, and we did the correct curvature math to find out how big of a ball would you need to be able to see that ship. And the answer was, I believe, over 1,000 times bigger.
Oh, shit. Okay. Okay, so my next question, you got the ships here.
There's 8,000 continents, not 8. So
you got the ships here, right? I guess my next question, seeing that you have this up, was with all the technology we have now, right, and the scientists and the telescopes, why doesn't one of them take one of those high-powered telescopes and zoom in straight across the Earth and see a city they shouldn't be able to see? Like, why would they hide that from us?
Okay, so if you had a high-powered telescope in your room, in that room that you're in right now, could you see the room that's on the other side of the wall? If you use the full mag, I'm asking you a question. Hang on. No, because the wall is opaque. Now, if it was a window, you could zoom through the window and see out there, right? But the wall is opaque. Air becomes opaque over distance, and light doesn't travel to it. So people, why can't I see the Eiffel Tower? Well, there's a whole bunch of reasons. One is, are you looking in the right place? Two, it's so small that because of the distance that you can't see it. And three, let's have a telescope will zoom in and help you, make things bigger. But the problem is it can't zoom in through an opaque sky. So let me show you an example of that. Do you see right now?
Yeah.
What if I turned off every light?
I probably see a little glow from the.
Nope.
Computer
I
screen.
turn off zero light. Zero light.
No, I wouldn't
Okay.
be able to see it.
Why is that? Because you're not seeing me. You're seeing the light. Seeing the light that's
Right.
bouncing off of me.
Right.
Okay.
Right.
So let's say I'm outside and it's really dark and I'm about a mile away from you, and you're able to see a mile. Okay. And I have just a little bit of light on my face. Might not be able to see me. That light might not make it to you. But if I had a flashlight, you're going to see the flashlight.
Right.
Right? Okay. So the flashlight's brighter than the light. So every year, 6 months, the sun goes into the Tropic of Cancer, and then it goes back out to the Tropic of Capricorn as it's doing its big circles. Okay. And twice a year, it passes over between this viewing point and Mount Cantico. Mount Cantico is 175 miles away. You can't see it because at that distance from this altitude, using globe curvature math, the top of the mountain should be over a half a mile below the curve. Well, behind the physical curve. Remember? Physical curve, behind the physical curve. However, twice a year, the sun lines up with the mountain, and the light that's bouncing off the mountain isn't strong enough to push through 175 miles of thick air. But the sunlight is like the flashlight. It's strong enough. And when it passes the mountain, it backlights it. And all of a sudden you can see the very top of this mountain right there should be over a half a mile below the curve. You know what the Globies say? The Globies go, well, the mountain is below the curve and the sun has already set. It's just refracting up and stopping at eye level to trick you. You're smarter than this.
Yeah, that doesn't make sense.
Thank you. See, you are smart. Okay.
Well,
It's not a mirage. Look at it. It's the sun going beyond it. Now, is the sun going below? Is the sun going down?
yeah, it's setting in that video.
Going down, or is it going away?
Looks like it's going down to me.
Okay, it looks like it's going down. Let's clear that out of your head. Okay, you're going to learn something new right now. All right. So, do you have water? Drink some water, man.
Thanks, buddy. Appreciate it.
Make sure it's structured.
Definitely
Sure.
some water. Sure. Okay. So let's say you're standing out in the street. It's 12 noon. The sun over you. Right? It's high in the sky above. Across the street is a 10-story high building. Right there. Okay, 10 stories. You're across the street from it. Sun is over your head. The sun's moving away, and it goes beyond the building. Now you can't see the sun anymore, right? As soon as it passes that building, because the building is literally right across the street from you, the sun moves away. So here we have our building, right? And the sun moves away, and now you can't see the sun anymore, right?
Okay.
Is that sun below the horizon, or is it just beyond the building?
It's past the building.
Past the building, but it's up.
From my point of
No,
view.
it's up
Right.
from your point of view. Now, how could you see that sun again? You can climb up a ladder 10 stories high, you'll see it. Or if you walked a mile the other direction, there's just an open field there, you get a better angle and you'll be able to see the sun.
Right.
Because at a mile away, the top of that building will appear to be at your eye level to you. It'll look like it's right there. There's the top of that building. It's at my eye level. Don't believe me? Go out and test it. Okay? Go out. If you live on the water, stand at the beach, look across. You know, I can look over at Long Island, which is 5, 6, 7 miles away, depending on where I'm looking. And the tops of those trees that are on the hills that are 100 feet high, that are 100-foot tall trees, the tops of those trees look like they're at my eye level. That's just how we see. It looks like it's at my eye level. So here we have our perspective grid, okay?
Mm-hmm.
Here's a guy, here's you. And your eye line is here.
I look good, man. That's good.
Yeah, fit, man. You're looking fit because with your new understanding, you're not on a spinning ball and a worthless piece of garbage. You called from a pond scum. You realize that you're at the center of creation and that you're important. Maybe you'll take care of your temple. All right. So, okay. I'm not saying you don't. I'm just saying.
Oh, I eat everything.
Okay. Well, gotta see. Yeah.
Oh. Joe's got to beat his dog. Hold on.
That's all right. What's this? So now I threw a mountain up and got the sun up here. Now the top of this mountain, is this above his eye level?
Yes. Yeah.
Let's say thousands of feet higher than he is. He's standing there looking at the mountain. There's the sun. Now the sun is just going to go away following that grid. And just like the sun did with the building, it's now behind the mountain. You know that it's not below the horizon because if you climb the mountain or
Plus,
you
it's
went
still light out.
Plus, it's still light out. So you're going backward. Let's say you're in a big field and you go 10 miles. Now the top of the mountain will be at your eye level. So let's push that mountain into the distance. Right? Still in the sides, still in the foreground.
Yeah.
Yeah.
Now you can see the sun. Now, this is the top of the mountain, which is thousands of feet above his eye level. And as the sun goes away, it goes beyond the mountain, just like it went beyond the building. Then we add the cloud layer in there. So you got these clouds. They're all at the same height, but the clouds also merge into a horizon for you the way you see it. So the sun is going to go beyond these clouds. And even if there wasn't clouds, the atmosphere literally merges into that horizontal eye zone and becomes opaque. So now the sun has gone beyond two horizons. A mountain horizon, which is thousands of feet above his eye level, and it went by an atmospheric horizon, which is thousands of feet above the mountain. Okay? But to you, it looks like it's at eye level and everything is going down.
Right. I'm with you. I'm with you.
That it?
Yeah.
Right? Movers will say, oh, if you go up higher, you don't see a flat earth. Not true. Here's a guy. We move him up. Right?
Yeah.
You can now see farther. I saw the sunset twice. Watched it, and I went to the top of the building and saw it set again in Dubai. Right? That's because you can see farther. You can see over things that are blocking your horizon.
Right.
Next. Welcome to the flat earth, by the way. Listen. Cross your type. And you're gonna want to just cling on to that ball. But if you want to do that, you have to admit you're in a religious cult.
Never. Okay, so my next question then. Eclipses, right? I'm sure you've answered this a million times. Eclipses. Why was it a lunar eclipse, right? Or which the sun blocks, or the Earth blocks the I'm sorry, right? I'm sorry.
You have to tell me what you understand about your model, because if you understood a tenth of what Joe and I understand about your model, you'd be a flat earther. But go ahead, tell me what kind of eclipse are we talking about?
The shape of the moon, right? Why when the moon blocks the sun, is it the shape of the moon on the Earth? Why is it a circle?
Okay.
Right, because on your little the thing that Joe has,
A solar eclipse,
Right.
right?
Yeah.
You're talking solar eclipse. That is when the moon blocks the sun, and you're saying the shadow on the Earth. So let me ask you a question. Put a basketball on the ground.
Okay.
and the sun is directly above you, or a street light or whatever. Okay, and the circle of the shadow of that basketball is pretty much about the size of the basketball, maybe a tiny bit bigger, right? Right? Shine a light down or the sun onto a basketball that's sitting on the ground, and that shadow, is it bigger or smaller than the basketball? About the same size when it's touching the ground,
yeah.
right?
Yeah.
But now, if you lift it up a foot, shadow get bigger or smaller? It gets bigger. What happens when you lift it up 5 feet? It gets bigger. What happens when you lift it up 10 feet? You know what happens when you lift up 10 feet?
Okay, I'm with you. Yeah.
The shadow disappears.
Yeah, exactly.
That when you get that basketball, do it where the sun or light is lower. That way you can hold it against the wall. You got your nice tight shadow. Move 20 feet from the wall. There's no shadow anymore.
Right.
It just disperses.
Right.
But they'll
the sun bounces off the other atmosphere.
And penumbra means that you're a goat and that you're just going to believe. Oh, that's a very fancy word. And I don't have to it's a cool word. And then they show you, they show you satanic symbols of the umbra and penumbra, which is a whole other thing. And people just go, I can't figure it out, so it has to be true, right? You can't cast a shadow 250,000 miles away and create a 70-mile circle, because when we have a full lunar eclipse, the circle is only about 70 miles.
Right.
Is that possible? Right?
Yeah, no.
Let's talk about why.
What about the impossible eclipse?
Well, what's an impossible? Is that like an impossible burger?
Don't eat that.
So here is, let's say you're here, because your position from your point of view is always the top of the Earth, right? Even though someone's upside down on the bottom, they think they're on the top. Okay.
Everybody's
Stupid.
on the top.
Laugh. And anything about the heliocentric model is laughable. Okay. So if the Earth goes in between the sun and the moon, the Earth's shadow will darken the moon, allegedly, right?
Right.
Okay. So what kind of eclipse is that? Is that a solar eclipse or a lunar eclipse?
That'd be the lunar eclipse, right?
Correct.
So why is there a curve on the face of the moon?
Question. We'll go to that next.
Okay.
So you're standing here. So the sun's light is lighting up the moon. The Earth is the moon and the sun. Could the eclipse start yet?
Not if it hasn't. Right. Yeah.
Not if it hasn't in a line. Okay.
Right.
So if we move it up, here comes the eclipse. Is this what it should look like?
Yeah, that's usually what it looks like, right? Yeah.
Okay. Could the shadow come in from the top as the Earth is moving up? Trick question.
No.
Okay, but it does sometimes. Not always. Sometimes. So there's eclipses where the eclipse starts while the Earth is still below the line between these two, and the shadow comes in from the top.
What?
Do you know how that happened? Yes.
What?
The last Selenian eclipse has been over 50 documented. It came in from the top. So, do you know how that happens?
No, not even close.
Neither do I. But we can rule out that it's the Earth doing it.
I'm gonna have to look that up.
And you know what scientists call that eclipse? They call it the impossible eclipse. The Selenian eclipse is also named the impossible eclipse, and nobody says boo about it. Wait, you're calling it the impossible eclipse? When you ask them about it, they go, well, it's an anomaly. Oh, that's a nice word. Right? Anomaly. Okay?
Very scientific.
And penumbra. And you're like, ooh, I remember that in school, and I don't want to think about that again. Okay? I don't want to think about that again.
This
right?
Celine
Right?
Leon.
Umbra and penumbra
no,
kind of looks like this symbol. Okay?
Oh, okay.
With the Freemasons.
That's kind of how your eyeballs work too, though, right? I remember that from some class.
Tell us what they tell us, and yeah, our eyes do flip things upside down, and it's a little bit crazy, but so back to eclipses, okay? So what I want to show you is, all right, here it is. So this is a solar eclipse, and we're told that the moon is blocking the sun by getting in between us and the sun.
Right.
Do you see the?
No.
No. What do you see?
Just the sun.
It's the missing sun. I call it missing sun.
Right.
Right? There's a piece of the sun missing. It looks like the sky is the same. Just a piece of the sun is missing. Like I can imagine a circle all the way around here, or maybe whatever this is. But is this really in front of the sun? Is this?
I think so.
You think so?
Yeah.
But why don't we see it? Here's a full eclipse. Why don't we see it? How come nobody has ever seen the moon approach the sun, eclipse the sun, or exit the face of the sun? They only see missing sky. This is missing sky, right? This is just a piece of the sun is missing.
Because the sun is so bright? I don't know.
Good answer. But there's been full eclipses that have very little ring of fire or no ring of fire, right? So you're looking at the moon, the sun is blotted out, and you can't see it. Cameras, infrared, zoom, space station, airplanes, nobody can friggin' see the moon. Now, when we see a full moon, it's because they tell us the sunlight is bouncing off the moon and coming back to our eyes. So if you went in the middle of nowhere where there's no lights or anything, you have a full moon, clear night, you could read by that moon. You could drive your car without the lights on. The moon's that bright. The moon will cast your shadow on the ground. Well, if you're on the moon during a solar eclipse looking at the Earth, it's a full Earth. Earth is 6 times bigger than the moon, and I claim it's a little more reflective with all the water and everything. So the Earth shine should be at least 6 times as strong as the moonshine.
How would anybody know that, though? Has anybody been on the moon during a solar eclipse?
Nobody has ever. Oh, how come?
That's what I'm saying. So how would somebody know that you could still see the Earth?
Well, but you're right. So
Okay.
the Earth, here's the moon,
I
and
got
as the
one.
moon goes, it rotates. If that's what they tell us, so it's the same size that all the time. Where would a great place to put a camera be to monitor the Earth spinning in space? Right here on the moon, because no matter where the moon is, it stays facing the Earth. Put a camera there, live stream the spinning of the Earth, hurricanes, eclipses. It'll be amazing. Nope.
I agree.
Can't do it. Can't do it. You know why they can't do it? Because a GoPro camera doesn't fit in their $80 million a day budget. Okay? Couple solar panels, right? We got a thing on Mars, the rover. We get into that. Okay? And that thing's working for 20 fucking years. And it has dust all over the solar panels, but then clean the next day.
Isn't the rover in Greenland?
Yeah. Well, Greenland, that's another thing. And, I have a whole thing, but I don't want to get into that yet. I can get it. If we have time, I'll get into it.
Oh, I got another question. Okay. So on your, the flat Earth, what do you call it? I'm sorry. Where
Sun,
it
Moon,
shows.
Zodiac clock app.
It shows that, right? So I saw somebody bring this up on another, because I'm trying to learn more about this, right? So I saw somebody bring up that the inside circle, right, is smaller than the outside circle, right? So if the Earth or the sun is going around the inside circle, right?
Wouldn't it have to be going
Right, yeah.
faster?
Yes, wouldn't it have to
It
go
does.
faster on the outside than it does on the inside?
That's why the
Okay.
days are shorter and longer in certain spots.
Wait, what?
Going
Say
fast.
again?
So this is the hour hand. It's circling around once every 24 hours. I have it on
Right.
time lapse. Right?
Mhm.
So out here is the tip of this hour hand going faster than this part of the hour hand. It is. It's going the same angular speed, but it's linear speed. This is slower. This is faster. Right?
So
if I had a 20-foot stick and I'm spinning around, my hand, which is 3 feet, makes a 6-foot circle, 6-foot diameter circle. The tip of that is making a 52-foot circle, but I'm spinning
Right.
at the same speed. It's going faster, while my fist is going slower, but the angular speed and degrees per second per minute, whatever, is the same. Makes sense? Yes.
Yes. So, but if that's the case, during the summer in New York or whatever, wouldn't the days be shorter because the sun's moving faster?
What, in the winter? You don't think the days are shorter in New York?
No, no,
And it
no.
gets
In the summer in New York, when the days are the longest, if
When
if
the days are
the
the-
sun is moving at the same,
Hold on. In New York, in the summer, the sun is closer and moving slower. So one closer makes it higher, so we can see it for longer, and it's moving. That's why we have long days. Where are you located?
I'm in the West Coast,
Okay, but in where? What state?
California, Southern California.
Yeah, in June when the sun sets, how long is it still light before it's really dark? Like almost 2 hours, right? Are you in Northern
time.
California? Yeah,
No,
yeah.
Southern.
So, all right. Well, here in Connecticut, in June when the sun sets, it's about an hour and 45 minutes before it's dark.
Hold on,
Right, sunset.
Connecticut.
In Connecticut,
How about that New Haven pizza, baby?
yeah, there's great pizzas here. There's great pizza.
All right.
Don't eat that shit.
Okay.
Cold
So-
fired. Let's go. Anyways, let's go.
So that's why we have longer days and lingering light because the sun is moving slower and it's closer, which makes it higher.
And hotter.
Okay, you with?
Yeah.
So, hang on. Let me just blow your mind for a second. Well, this is very easy. So but the thing is, you weren't ever taught to think. You were only taught to memorize, and you probably only did minutes on that, right?
China.
Actually gives you an advantage. If you
Yeah.
taught you have an advantage because you have a clean slate. Okay. Yeah, you know it. Okay.
This is a nice guy. I need you around more often, man. You're
All
very, very nice guy.
All right. So the sun goes away, and on a ball, it should be going down, and it should never stop. It should just keep on going. But here is the day where I filmed it super clear with my drone. It was below freezing, and the sun went down, 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 and then it stopped. And it sat here for 10 minutes. Now, my friends at the park down here saw the sun set from the bottom up 10 minutes earlier. I'm still watching the sun. This is super sped up. It's not going down anymore. It's just going away and taking its lingering light with it. Okay? And now you can't see it because the sun can't even push through the clear air at that distance. Forward and back there, forward and back. All right? So getting back to in our here in New York, the sun's close, going slower. Now on a ball, right? On a ball, America, right? During our summer,
USA.
we have our lingering light in June and July. But 6 months later, Australia, South America, has the same angle and tilt. So they should have a lingering light also, right? Because it's going around here. They should have anything we have 6 months apart. Our winter, their summer, our summer, their winter. Okay? We have guys now that are measuring the sun in different locations. One of them's in Australia. And right now, the sun is moving its way out to Australia, which would be their summer, which would mean that they would have to have the same light characteristics that we have here. But what he's finding is each day he measures from sunset until it's dark. And each day it's getting longer and longer. It's getting darker faster. Even though the sun's coming towards him, it's getting darker faster. And guess what? It's getting darker faster for us here. getting darker faster for people here. Everywhere in the world, it's getting darker faster. Now, depending on your latitude, depends on when the sun will rise, how long your day is, and when the sun will set. But from set to dark should be reciprocal in the north and south. They should match 6 months apart, but they don't. In December, the light goes fast for everybody. In December, there's places in the south that when it gets dark, 5 minutes later, it's pitch black. In June, even though they have shorter days in the south because the sun's far away, the sun lingers like it does here. So no matter where you are, you can't compare the amount of sunset to dark that you have with other locations. You can only compare it to yourself at the same location for the year. And what you'll find is the sun lingers in June everywhere, and it doesn't linger in December. Everywhere. That leads you to flat Earth. That's impossible on a ball. There's no
Okay.
My next question.
that's a year's worth of observations, and like, who are you going to believe? And you got to do it yourself. Go, and people are like, well, I was measuring it, but then I got busy, and I was at work and I was here and whatever. And then, people don't take these measurements. We're taking them. Yeah.
No, that's good. I'm glad somebody is. I guess my next question is on your flat Earth model there. So like, as you see the sun, it illuminates half of the Earth, right? How come it doesn't go further? How come it's always half? Right? So that would make sense on a globe model.
Well,
right?
no. Thank you. On a globe model, no matter what the tilt, time of day, angle, time of year, or anything, exactly half of the Earth should be lit at all times.
Right. Well,
Not the case in reality. Okay? But you already passed the equinox. Okay? The equinox was was a straight line between day and night. But watch, I'm going to move the sun from October, November. Look at it now. This light is wrapping around. December, even more, right?
Dave, wasn't there a newscast where they were like 97% of the Earth is lit up?
Let me get you there. Okay. So February, March.
I wish I was lit up right now. Boy, that'd be cool.
Okay. Look, March 50-50. That must be the equinox.
Right.
Okay. Right.
Okay. Cool. All right, I'm gonna take it away. My next question. I'm gonna take it away from what's up above us.
Please, I just address the thing that that he was showing you. So here is the Gleason's map. Okay. And it's the best map that we have. And so here, where are we going here? All right. So on July 8th every year, they say 99% of the population is in some form of daylight. Whether it's twilight, but it's daylight. 99. That's not 99% of the Earth. Flat Earth, that would be a death blow. It's like 70% of the Earth because everybody lives in the north. So it's kind of tricky, but still 51% of the Earth in light, it wouldn't work. A ball is 50% dark, 50% light. Yes, there's a little blending in there because of atmosphere, but it should be equal light and equal dark at all times. But that's not the case of what happens on this day. And so here we have a ball, okay? And here we have the map. And if we just shine a light on the areas on the ball, right? We're showing. I wish I have a great video on this. It's on my channel. It shows that Australia, California had light. All of this was in light, and the only thing that wasn't in light was the tip of Santiago and Australia and New Zealand. Okay. Where is it? Hold on. Maybe this is what I was trying to show. Yeah. Okay. So here we go. So we're showing the light that day and night shows, right? And we're lighting up the same area. Those are the only two areas over here that are in the dark, right? On a ball, you can't get all of that area into that part of the ball because it covers another third of the planet. It covers another third of it, all right? So All of this end is left out. All of this is left out on the ball. It doesn't work on a ball, it works on a flat earth. Hard to show here. Got a video on my channel, DITRH. I believe it's called Day and Night or 99% or something like that. You'll find it.
So my next question, right? So let's say we live on a flat Earth.
We do.
We do?
Well, okay, let's say. Crazy fucking people. What's beneath us? What's underneath? What's down there?
I don't know.
I,
Want to know? You want to know?
what? Yeah, I want to know.
You want to know underneath?
That's why.
So do I.
asked the questions.
So do I, right? Here's the thing. You ever hear of the Cora borehole?
No,
The
I've heard
ultra-
cornhole.
Cornhole, of course you have. Okay. It's in Russia. United States worked on it. It was literally they were just drilling down, and they were drilling for years and years and years, and they were using ground penetrating radar to see what they're going to hit, and it was wrong every step of the way. Wrong, wrong, wrong. No more rocks, hit rocks. No more water, hit water. Right. And then they got to about 7.8 miles, less than 8 miles, and they hit an impenetrable barrier. It just got too hot. They couldn't drill. They tried everything. Nothing worked. Some crazy stories came out of there too. So they were wrong digging the first 8 miles. Okay, right? Let's put that into comparison. If you had a Macintosh apple, they have the thin skin, Macintosh, nice and thin. You drilled a quarter of the way through that skin. And you were wrong every step of the way on what you were going to hit. Okay? You're wrong every step of the way, but then you go, all right, we give up. I know what the next 4,000 miles is.
Sir, can you take the apple down? You're making Joe real hungry right now.
Well, so what is this at the center of the earth? First, this is a pseudoscientific meme with zero evidence. This is a cult following this. But what is
Right.
this? What is this little glowing part?
Magma.
Magma. This is all magma, but this is what gives us our magnetic field. What is this? What do they tell us? Is at the
Lava,
center?
molten lava.
No,
I'm not sure.
they tell us we have our magnetic core, our molten magnetic core. Okay, say it, molten
Okay.
magnetic. You can't have molten magnet because
There's
any
no
magnet
anymore.
it up before it melts, it hits what's called the Curie point, and it can no longer hold magnetism. So they couldn't get below 7.8 miles. They were wrong in that 7.8 miles, but they know the next close to 4,000 miles exactly what it is, and there's a scientifically impossible molten magnet there. Okay, that is a religious cult belief.
Oh my god. Yeah. Okay. I'm with you. Maybe Elon
All right.
can figure it out. 'Cause he's-
Yeah, show him SpaceX rocket in the car, and
You don't like Elon?
he's
Come
controlled
on.
opposition
This guy, right? Elon,
Yeah,
and
with
Elon.
his Satan suit on.
but Twitter logo. Okay, it's
Freemason
literally
logo.
it's Freemasonic sign. But let me show you. I want to show you. Well, I got to word it a different way, but I'm going to show you a rocket launch. Okay, where is it? And we're going to. Where is the one that I want? This is
Okay, I thought of another question while you pull it up. Where do meteors come from?
that's a great question.
Yeah.
I don't know, man. No, I do actually have an answer for you. I was just like,
Oh.
where is? Why do I have to find a new place to put this because it's always moving on me.
So we just released our episode this morning called it's basically about history being fake, and all those guys around the world, I believe, are where the mud floods came from.
Say that again.
You know the Tartarian mud. Well, you know the Tartarian mud floods. We did an episode about how history is fake, and I was showing them all the buildings and all that, and the mud floods. I think that's where all the meteor holes are from water that came out of them and caused the mud floods. But that's just a theory.
I actually agree with that. So so this is Elon Musk. This is a rocket. He's testing it, right? And we have edit, right? So look how slow this is moving. This little like gas flame, right? There's more power comes out of my gas stove when I'm cooking eggs in the morning. Okay. It's lifting this multi-ton rocket up. Okay. And it's having little engine issues right now. And then all of a sudden it's this high. And then this isn't high. I'm filming it from the side. I can see the bottom and the side. How far is that thing? Right? Because if you're going, and now it turns off. So now this is multi-tons, free falling. Now look at the smoke. How fast is this thing moving? And watch when they edit, the smoke changes speed. Look at that now. Is this free falling at 1,000 miles an hour plus? Now, whoa, how'd it get so high? Okay. This is their live stream. Now this thing is free falling. Look at this. It looks like the old little space show that you used to watch as a kid. What's the animated one called? Right now it's up high again. And then watch. 3 engines are going to come on. It's magically going to turn upright. Edit film. Cameraman gets underneath it. 2 of the 3 steering engines burn out because they can't even get their little fireworks right. So now you got one off-sided engine. It's going to land this thing in a bunch of CGI smoke. Ready? CGI smoke. There it is. And it lands upright. And it looks like a dick. Okay? Okay? Now, if I said it's a B movie or is this an Elon Musk rocket launch, what would you say?
Oh, it's a.
Right? I might be fooling you. This is B movie or is this a real rocket launch from SpaceX? Which one is it?
That is the rocket launch from SpaceX. I remember watching it on the news.
So, but you have common sense, and you know that what I just showed you is
Looks
impossible.
like dog shit.
Dog shit. Dog shit looks better. All right. So, why is Elon Musk faking rocket launches? I'll tell you how you know this. Go to my website, flatearthdave.com. Scroll down to the banner that has all the pictures of Elon Musk on it. 5-minute video. You'll find out that he's a fraud in every single thing he does. He's a puppet for the elite. Gravity. Sure you want to do gravity?
I already debunked
gravity.
gravity last episode. He's like, it's because we have muscles and skeleton, and that's how we can walk around and we're not stuck to the ground. Get the...
Yeah, exactly.
What's gravity?
What do you mean the Earth's gravity?
Well, they give up Newtonian gravity, which is mass attracting mass, and now they say it's Einsteinian of the bending and warping of space-time. So
Right.
that's the one that we're supposed to use. Hey, do you know what the bending and warping of space-time is? You know what that means? Nobody knows what it means. It's a bunch of nonsense. It's just like, I have to appeal to authority to get by that one because I don't want to admit that I don't know what it means. Nobody knows what it means.
I'm sure. I mean, there's got to be somebody.
They show you the big drum with the sheet on it and the bowling ball in the middle, bending space-time, right? Then they roll the balls around it, right? And they orbit around it. That's the bending of space-time. Why is it going down? Why isn't it going sideways? Why does it bend it in every single direction? Why is there a down? I'll tell you why there's a down. Because the Earth is neutral. Okay? The Earth is negatively charged, if you will, and everything in the sky is positively charged. And
I think
the Earth is. Go ahead.
I think being down kind of implies that there's gravity, right? No matter where you are on the planet, down is because of gravity, no?
No.
Well, that's what you want to think. So, excuse me. So, this is what flat earthers say. Australia, Americas, right? Down is down for all of us. That's crazy, right? You, not only do you say down is in all of these directions, that we're spinning and orbiting and twirling in 4 different directions at once, but down is always towards the center. Why is down towards the center? Why is it the center that says everything come to me? How about if you were a molecule and you're at the center, you're like, I'm king, everything come to me. And then Joe, he's halfway between you and the surface. He goes, no, everyone come to me, right? Wouldn't all the gravities, the microgravities cancel each other out? Why is it only the center point that pulls everybody in? Why doesn't all of the other dirt pull everything else in every other different way?
Because we're not big enough to generate our own gravity.
I'm talking about why does the Earth pull everything to the center? Why doesn't it pull it to another? Why is it the center? Okay. So here's the question. Got this balloon here, just holding it and sagging down.
Looks like my
Why
balls.
isn't it stretched down? Why isn't it, you have yellow balls? Nice.
I mean,
Isn't it being stretched
I'm a
down?
little jaundice.
Hold on. If
More like
gravity,
my balls, yes.
Make joke.
I'm
I
sorry,
get-
it's what I do.
Your jokes are the best global proofs you have. Okay, so if there's more gravity, it could hypothetically stretch the rubber, right? If the gravity was
Yeah.
stronger, it might pull the rubber down, right?
If it had more mass or density, right, it would.
Gravity was stronger, so this is what 1G does. If we increase it to 2Gs, maybe it would go like that. 3Gs, maybe it would go like that.
Right.
The only answer that the globies have for why doesn't the air go off into space, they go, gravity's holding the air down. Okay? But again, we can take our little vacuum box and open it up and it'll suck air and water up and away from Earth in a split second violently. So if we take this and we put some air in it, what is this air trying to do? It's trying to escape in all directions, including up, left, right, down. It's trying to escape. The air is strong enough to stretch the rubber, but the gravity isn't. How's the gravity going to hold on to the air? Okay? Right? So Walter Lewin from MIT, famous professor, says it's electric forces that hold our world together. Okay? Electric forces hold our world together. Interesting. Okay? So we can see evidence of static charges everywhere. We can see, we can prove the electrostatic force. Okay, so as I said, the Earth has a negative charge, and everything above it in the air is surrounded by a positive charge. Buoyancy and density. This blimp is less dense than the ship, which is less dense than the water, which is the submarine's more dense than the water. This is how things sort themselves out, buoyancy and density. But why down? Why not sideways? Why not that way? Why do things go down? Okay. So as I said, the Earth, we live in this electrical system, provable. I believe the sun and the moon are the anode and cathode. The land is the salt bridge. The salt water carries a current. That creates a battery, right? Go back to chemistry class. You'll learn about that. Okay. And so we live in this free energy system, right? So another question is, if gravity can hold down the air, how come it can't hold down trillions of tons of water in clouds? Isn't that heavier than the air? What holds a cloud in the air? The answer is electrostatics, okay? Electrostatics.
I mean, again, I'm no scientist, but one might argue that our God dang it, I would lose the word. Our not the ozone layer, but our atmosphere holds the air in, right? And then when a cloud goes up,
our atmosphere is the air. There's no argument. There's no one makes that argument. You made that up. All right. So
yeah, one might argue. I am one.
So look, we're putting negative charge into this, and it's repulling away. It's pulling away. Two negatives will repulse, and this thing is floating in the air. It's by putting a negative charge into it. All right. And then if we do this, some helium balloons, okay, and we got it tied, and we have a little button here, and we have this cord. It's just neutrally buoyant a couple inches off the floor, and this cord goes to a Van de Graaff generator, and we're going to add a higher positive charge to this. Now, we're not making it heavier. We're just adding a positive charge, and it gets heavier for some reason. Right? We didn't add anything to it. And then when we discharge it, it goes back up. So I just proved that the electrostatic force can be manipulated, and it will make things heavier. Okay? Am I defying gravity or electrostatics? All right? So just one more thing. This is a silent drone. They say it runs on ionic wind. There's no moving parts. It flies just by changing its electrostatic force. Okay? There's no moving parts, but it flies. All right? So here's the catcher. Here's the kicker. Okay? They say that the now science, the science cult leaders, and I don't believe I don't believe what they say. I don't believe that they're
Scientists.
that they're right. All right, the scientists. I don't believe that they're right. You know what? When you say 10, and they say that the electrostatic force is 10 to the 36 power stronger than gravity. They also tell us gravity is a weak force. It's very weak. Gravity's weak. Okay. Well, they say the electrostatic force, which I just demonstrated with those experiments, it can lift things off the ground. It's overpowering gravity or the electrostatic force. They say the electrostatic force is 10 to the 36 power stronger than gravity. 10 to the 36. No human can fathom what that number means, right? How long is a trillion seconds? If you guess it within 2 days, I'll give you $1,000.
Can I guess it?
1
No.
year.
Oh, what you want to round it off? Up and down? 1 year, 1 week? When you want to?
Just a year. I'm good.
Okay, 31,000 years. Okay, okay. Big number is. How big that number is? 31,000 years. That's 10 to the 15th power. All right, 10 to the 15th power. Now, if I was in there and I gave you a buddy punch in the arm, and you're like, no, that didn't hurt at all. If it was 100 times harder, it'd probably knock you off your chair. If it was 1,000 times harder, it'd probably break your shoulder. If it was 100,000 times harder, it would definitely snap your spine and kill you. And if it was 1,000,000 times harder, it would probably blow up the house. And if it was 1,000,000,000 times harder, I think I would have to believe in nuclear bombs or something, because that's the force of that.
Me?
You're trying to fight me?
And then
You trying to fight me?
in times harder, you can't even fathom what that would be. That's 10 to the 15th. So now we have to go all the way up to 36 zeros.
Like,
And that's how much stronger the electrostatic force is over gravity, according to mainstream science. So let's say gravity was in charge of making this go down, and it is 10 to the 36 less than the electrostatic force I just demonstrated. If I let it go, it would probably take 1,000,000 years before it would go down, because the gravitational force is effectively zero. So they're telling us the truth again. The electrostatic force is 10 to the 36 power stronger than gravity, which means gravity is not a force. They're telling us.
Dave, you just said a lot of words and a lot of numbers.
I understand, and I think
I zoned
I think-
out for like half of that, bro. I'm just,
Right.
that was a lot, man.
That's it.
Um,
I'm gonna wrap this up because I gotta save my voice. I have another show, and we're going over. Question to you:
Yes, sir.
Are you in a cult? Are you in a cult?
Sex cult. Sundays through Thursdays usually. I'm tied up.
You're stupid, dude.
Do you believe you live in a cult, Dan?
I'm still open-minded. That being said, I don't know why thousands and thousands of scientists would all want to do experiments and lie to us, what they're getting out of it. And frankly, at the end of the day, until I blast off in a rocket ship and see the Earth for myself, whether it be flat or round, I don't know. And honestly, whether it's round or flat, guess what? Tomorrow I gotta get up and put my fucking pants on, take my fat ass to work, and do the same shit. So it really doesn't matter.
Say the same thing. Now I don't have to go to work. Okay, so
He said the two worst things ever. Why the lie and fucking I gotta go to work tomorrow. Both those things are bullshit.
in a room,
no,
and there was
both of
50
those are
dead,
real.
walked into a room, and there was 50 dead people hacked to death, and Joe's going, "Oh my God, this is crazy! You're crazy!" And you look around and go, "What's the motive? Why would people lie about this?" And you just don't believe it, right? Well, that's ridiculous. You look at the evidence. I showed you the evidence. The Earth is not a spinning ball. A spinning ball is scientifically impossible. It does matter. And you're required after this conversation to get my app and go to the frequently asked questions page and hit the why the lie, and then watch those videos this week. Okay?
Okay,
Watch them on
I'll check it out.
while you're out eating your Fritos or whatever you eat, and then you'll be like, "Whoa, oh, I get it. All right, guys.
For the record, I eat everything. need
I
you to know
understand.
that. It's not just
See-
Fritos.
Yes, I get it.
Dave,
And,
it's been a
you know-
pleasure, man. Thank you.
All
I
right.
appreciate your time, brother.
Thanks, brother. And the
Thanks, Dave.
Earth is not deal with it.
Hey, Dave. Godspeed.
Yeah.
Godspeed,
See you
Dave.
guys. Thanks for having me. See ya. Bye.
Hey, you reached Joe, and leave us a message when you get a chance. I can't tell who's calling because the screen on my flip phone has broken.
Hey Joe, it's me. Just wanted to say thanks for not telling me who the guest of our podcast was going to be. I'm setting up a sparring match for you next week, and I'm not going to tell you that the guy you're sparring against is Mike Tyson, dick. So have fun with that. That being said, the earth is...